Okay, welcome to part 4 of section 2.4. We got one goal left, which is to do parallel and perpendicular lines. And I guess a big part is to write equations, but a huge part is just to remember what parallel and perpendicular are and how they work, and it's particularly how their slopes work. There's a lot going on in this section. I'm going to kind of fly through a lot of it, so pause or rewatch it if you need to. And just focus on this idea of what do you remember about parallel and perpendicular lines and their equations. All right, so here we go. I got a line that here graphed. It's got a slope of 1/2 and a y-intercept of -2. Right, so you can see it graphed down here. And so I want to know what is going to be the slope. Not worry about the whole equation, right? This whole thing is the equation. But just what would be the slope of a line that's parallel. So if I drew some lines, and I'm terrible at drawing lines with my little thing here, but these are, imagine that those are parallel to the blue line. What do you think is going to be true of their slopes? All right, so take a second, think about that before continuing. Okay, and hopefully you see that all of these, they have different y-intercept numbers, right? They all have different y-intercept numbers, but their slopes are all 1/2. All right, so for parallel lines, their slopes are the same. Okay, and what will happen is if I took the equation, say, of this line, maybe I'll highlight it or start with red here. If I want to write the equation of that line, it's going to have the same slope of 1/2. So we're going to have 1/2 x, same as before. And all that's different is now the y-intercept is 4. Okay, so when you have a pair of parallel lines, you have two equations because there's two lines, and their slopes are the same, but their y-intercepts are different. All right, so let's do this with perpendicular then, right? So parallel lines have the same slope, different y-intercepts. All right, so I'm going to attempt to draw some perpendicular lines to my blue line. So it's the same equation as before, this 1/2 x minus 2. All right, and now I'm going to attempt to draw some perpendicular lines here quick. Well, that's rough. All right, you deserve better than that. Let's try that. Oh, that one's pretty good. Oh, rough. All right. But they have to make a right angle, so that's what I'm trying to draw here. Oh, struggle bus. All right, there we go. So the point is, all of these lines are perpendicular. So what do you think is true of these slopes? All right, and hopefully what you'll remember is that our original line has slope of 1/2, and for perpendicular lines you flip it. So I make it 2/1, and then change the sign. So this was a positive 1/2 slope, so our perpendicular slope is -1/2, right? And you can kind of see a -1/2, -2, right? So if you could kind of see, that's actually the slope of these lines here is -2. So for perpendicular, you flip it and do the reciprocal. So if I took another and change the sign, sorry, you flip it and change the sign. So if I had, say, a -3/4 slope, then a perpendicular slope would flip 4 and 3 and then change the sign. This was a negative, so now we have a positive slope. So perpendicular slopes look like that, where they're reciprocals and one is positive, one is negative. Okay, another quick activity for you here. I know there's got a lot on this page, but let's just draw a line here. Let's just do these top 6. These are pairs of lines, and your goal is to say, are they parallel, perpendicular, or neither? Right, so pause the video and label these quick. You don't have to write them all down in your notes, but just go through and mentally say, hey, which one do you think it is before continuing? All right, here we go. So this first blue pair is going to be parallel because they have the same slope of 3. The green one is neither. The slopes are pretty different, and they're not opposite reciprocal ones. Next one is, again, neither. They are one positive, one negative, but they're not reciprocals. I don't know what color this is. Mauve, whatever color this is, but the slopes here, that is perpendicular because they're flipped, and then one is positive, one is negative. Purple one, those are reciprocals. They're flipped, right? If you take 2/1 and flip, you get 1/2, but they're not one positive, one negative, so that one's neither also. And our last case, let's see, 3/9 is like 1/3. So if I flip that, it would be 3/1, and the sign is flipped. So that one is going to be a perpendicular because they're reciprocals, and one is positive, one is negative. Okay, so next up is we're not doing equations yet. We just want to do the slope, right? Remember, all the slope is like a ratio of like the y change to the x change. All right, so we're not doing a full-blown equation. This is just asking us, given a line, I want to find slopes for a parallel line and slopes for a perpendicular. So it's just asking about slope. All right, any thoughts? How are we going to do this, right? I can't tell the slope. Like on this previous one, we could tell the slopes really easily. But in this case, what do we got to do here first? Any thoughts? Okay, so the answer is we have to find the slope. And to do that, the easiest way is going to be to put it in mx plus b form, right? Because once you have it in that form, whatever in front of x is our slope, right? So this would just be minus 5x. So it would be 15 minus 5x. And then, so take away 5x from both sides, then divide by 3. So we get y equals 5 minus 5 thirds x. Okay, so our slope for the original line up here is negative 5 over 3. So for parallel, it's the same slope. For perpendicular, we flip it and then change the sign. Okay, and again, I'm not doing a full equation, saying just the slope. Right, we're going to do full equation questions here in 1 second, but these ones are asking just for the slope. Okay, so final thing to do today is these questions. I think that just understanding what we're doing is so important here because kids, I think, just don't even understand that part of it. So we're going to write an equation of a line that is parallel to this line. Okay, so I'm just going to stop there for a second and actually just graph this line. All right, so our original line here, which I'll do in red, has a y-intercept of 4 and a slope of 3. So it's going to go up 3 over 1. Okay, so I'm just going to draw that line. Okay, so we've graphed this initial line. All right, and so we want to do a new equation. So we're going to write an equation, okay, of a line that's parallel to this one and goes through this point. Okay, so we're going to have a whole new y equals mx plus b for our second line, right? Because there's 2 lines, so there's 2 equations, right? And we know it's going to be parallel to this line. Oh, that is not parallel. That is perpendicular. Okay, so parallel times oh man, I'm struggling with this parallel line idea. Okay, so imagine these lines are parallel to the red line. Okay, so there's lots of them, but we want the one that specifically goes through this point, that goes through 1, negative 2, which is right here. Okay, so our goal is to get an equation for that, right? So I'm going to get rid of all that junk and just draw that particular point, 1, negative 2. All right, so this is the line we're looking for right there. Goes through that point and is parallel to the red line. Okay, so the trick is we know the slope is going to be the same. So we're going to use the same 3 slope. You can even see that visually that the slope is 3. But b, right, the y-intercept, we kind of guesstimate what it is down here and draw this accurately and figure it out. But an alternate route you can do to find b is you can temporarily put these in for y and x and find b. So I'm going to take my second equation here and temporarily make y negative 2 and make x 1 and say, okay, if those things are true, to make everything equal, what would b have to be? Okay, and so we'll get this statement of 3 plus b has to equal negative 2. And if you minus 3 from both sides, you get the intercept to be negative 5. Okay, and if you plug that in, that completes our equation. Right, it's got the same slope of 3 and a different y-intercept of negative 5. Okay, so if we compare this to our original line way back up here, they're parallel because they have the same slope, and then just a different y-intercept because the second line goes through this point. Okay, so I can't stress that enough. There's 2 equations because there's 2 different lines. Okay, I'm going to do one more case just with a perpendicular situation. Okay, so I'm not going to graph this one. It's got a kind of a lot going on. But the idea is I need to find the slope, right? So I have to be perpendicular to the given line. Okay, so in order to do that, I need to find the slope of this. So I'm going to, again, fly through this part because hopefully you're getting good at this. I'm going to solve it for y so that I have it in slope-intercept form. Okay, so I would minus x first from both sides to start to get it into y equals form, get y alone. Right, now divide by 3, divide that whole side by 3, so I have -1 minus 1/3 x. Okay, and there's my slope, -1/3. Okay, so I'm going to do a new color because I'm doing a whole new line that's perpendicular to that red line. Right, so I'm just going to say, okay, I got a whole new equation because it's different lines with different equation. What I do know is if it's perpendicular, right, I can take my old slope and do the reciprocal and then flip the sign. Okay, so in this case, flip the 1 and the 3 and change the sign. Okay, so now for this new line, to make it perpendicular, I know its slope has to be opposite and reciprocal. Okay, and then it's the exact same thing as before, where I want to find this b, I want to find this y-intercept, right? So it's just like the previous question, where we can plug in the point for x and y. That's what we did right there, plug it in, and then solve it for b. Okay, so if I do that here, I'm going to put -4 for y, I'm going to put 1 for x, and b is unknown at this time. And then if I solve this, 3 times 1 is 3, and then -3 from both sides, we get -7 equals b. Okay, and I can plug that back in. All right, so my equation is y equals 3x minus 7. Okay, so now we have a pair of lines that are perpendicular. They gave us one line and we found the one that was perpendicular to it. Right, so it's opposite reciprocal slope and a different y-intercept. All right, that's all I got for parallel perpendicular.